Hey, so we all heard from your sister Kylie that you're trying to convince your parents to let you go to a tanning salon. Maybe you think that being tan would look cool. Maybe you want to be like those college students we see on the beach all the time. Yeah, a tan might look cute for a while, but you'd be making the worst mistake of your life, Anna. Just because these people do it doesn't mean that it's good for you. Take it from your friends. Tanning isn't worth the damage it does to your skin. In the long run, tanning will just make you age faster, and it can even kill you. So you understand how serious this is, we have to explain how the skin works. Yeah, this might be a bit tedious, so just bear with us.
The skin is the outer covering of your body and the largest organ. That much you probably already knew, Anna, but the skin is more than a simple covering. The skin is composed of numerous tissues and structures that together are called the integumentary system. The integumentary system has many important functions in your body. It acts as a tough but flexible barrier between your body and the outside environment, prevents water loss, houses nerve receptors, regulates your body temperature, excretes waste, and synthesizes chemicals such as vitamin D. Many of these functions are carried out by the dermis. The dermis is the inner layer of skin containing hair follicles, sebaceous glands, sweat glands, muscles, nerves, and blood vessels. The dermis, which is composed primarily of connective tissue, also contains networks of collagen and elastin, proteins which give the skin its strength and elasticity. This is important in maintaining the smooth, useful appearance of your skin. Underneath the epidermis is the subcutaneous tissue, which is mostly composed of loose connective tissue and adipose tissue, or fat. The main purpose of this layer is to bind the skin to underlying tissues such as muscle or bone and provide cushioning for the body. However, our focus is the epidermis, the outer layer of the skin which lies directly above the dermis. The epidermis is composed of stratified squamous tissue, keratinocytes, and is divided into 5 layers. The deepest layer of the epidermis is the basal layer, also known as the stratum basale. This is where all of the cell division in the epidermis takes place. Stem cells in the stratum basale undergo mitosis, creating keratinocytes, the basic cell of the epidermis. Also found in the stratum basale are melanocytes, cells that produce and deposit melanin into keratinocytes. Keep the melanocytes in mind, Anna, because we'll go back to these later. The other 4 layers of the epidermis are formed by keratinocytes. From top to bottom, you have the stratum corneum, the stratum lucidum, which is only found in thick skin such as your palms and soles, the stratum granulosum, and the stratum spinosum. As newer keratinocytes are created, older keratinocytes are pushed upward toward the skin surface. These keratinocytes gradually become keratinized, or filled with the protein keratin, and subsequently harden and flatten. By the time the keratinocytes reach the stratum corneum, they have become dead, scaly, and completely keratinized, forming a durable barrier. So, what does any of this have to do with tanning? Let's go off tangent a bit, Anna, and look at some sunlight. Sunlight contains ultraviolet radiation, which has an important role in tanning. There are 2 types of UV radiation, UVA and UVB. UVA radiation penetrates down through the epidermis into the dermis, while UVB radiation only penetrates part of the epidermis. When UVA rays reach the stratum basale, receptors on the cell membrane of the melanocytes are stimulated, activating the enzyme tyrosinase. Tyrosinase converts the amino acid tyrosine into melanin, a pigment that determines skin color. The produced melanin is put into vesicles called melanosomes, which are carried up to dendrites, which are cellular processes of the melanosomes extending through the keratinocytes. The melanosomes are then phagocytized by the keratinocyte. They migrate to the superficial side of the nucleus, where they can shield the DNA in the nucleus from damage caused by UV radiation. The accumulation of melanosomes and keratinocytes darkens the skin color, producing the tan. The darkness and longevity of a tan depend on several factors: the type of melanin produced, whether dark eumelanin or yellow-red pheomelanin, the amount of melanin produced, and how long it takes for the melanin to degrade. The number of melanocytes, however, isn't a factor because regardless of skin color, all humans have about the same number of melanocytes in their skin. Also, because keratinocytes are constantly being pushed toward the surface of the skin and sloughed off, a tan will fade if melanocytes don't have regular exposure to UV radiation. Dark-skinned people are able to produce greater amounts of dark eumelanin, which degrades slowly and remains in the keratinocyte until the keratinocyte is sloughed off. Because most of their skin cells have large amounts of eumelanin, their skin appears dark. However, people with fair skin like you, Anna, can't produce as much melanin, tend to produce more pheomelanin than eumelanin, and have melanin that is degraded quickly, and the upper layers of the epidermis become clear and pale because they have no remaining melanin within them, and what little melanin is seen is often the lighter pheomelanin.
A tanning bed is a device which emits ultraviolet radiation, usually in order to produce a tan. The UV radiation is mostly UVA rays. 97% of the radiation emitted from tanning beds is UVA, while only 3% is UVB rays. This is because UVB rays, which don't penetrate deeply into the epidermis, cause sunburns and do little in producing a tan, while UVA rays, which penetrate through the epidermis to the dermis, don't cause sunburn and stimulate melanin production and tanning. There are many types of tanning beds, which differ in design, orientation, material composition, and the number and wattage of lamps in the model, but they all use the same technology of fluorescent lamps.
Tanning beds use specialized fluorescent lamps to create the UV rays. When the fluorescent lamps in the tanning bed are turned on, this creates plasma, basically high-charged, freely moving electrons. In addition to plasma, a small amount of mercury is also found in the lamp. The plasma strips away electrons of the mercury atoms, which are ejected into phosphors found in the lamp. Phosphors are materials that, when stimulated by electrons, release light as photons. While in fluorescent light bulbs, the photon wavelengths are within the visible spectrum of light, fluorescent bulbs in tanning beds emit photons at higher wavelengths, producing UV radiation. The spectrum of radiation depends on the blend of phosphors used, and newer tanning beds usually try to imitate the spectrum of the sun. However, when compared to natural sunlight, tanning beds produce significantly more UVA than UVB radiation to speed up the tanning process and prevent sunburns. Also, even though the intensity and duration of the tanning session can be controlled, tanning beds still produce radiation at much higher intensity than the sun.
Maybe you think that if you are using a tanning bed, you're limiting your risk. However, this is what happens when you tan, Anna, regardless of what method you use. Whether you tan in a tanning bed or on the beach, you're exposing yourself to UVA and UVB rays. Both have harmful effects on skin. UVB rays, which are most intense during the summer and between 10 a.m. and 2 p.m. when sunlight is brightest, are responsible for causing damage to epidermal cells, which lead to sunburns. More dangerously, however, they can also react with DNA in the skin cells. A photon of UVB radiation can react with a DNA base pair and break the double bond between thymine and adenine. This allows the bases to react with neighboring bases. If two unbonded thymines are next to each other, they may covalently bond to form a thymine dimer. If additional bases react, the bases may form an abnormal ring formation in your DNA. This formation distorts the structure and sequence of DNA. If it isn't repaired, it can alter DNA transcription or replication, resulting in a mutation leading to a form of skin cancer. Because UV rays don't penetrate deep into the epidermis, the damage can be limited by apoptosis or programmed cell death, which we see as the peeling of skin after a sunburn. However, UVA rays penetrate deep into the skin where such action can't be taken as easily. Although UVA rays don't directly interact with DNA, when they stimulate the production of melanin, this also creates free radicals, which react with DNA in ways similar to UVB photons. The DNA damage can likewise lead to skin cancer, especially melanoma, the most deadly skin cancer. Since the location is deeper, apoptosis is not as effective, and the cancer is more likely to grow and spread. Free radicals produced by UVA rays also affect the networks of protein found in the dermis. Collagen fibers are damaged, stimulating the production of abnormal elastin. This in turn triggers metalloproteinases, enzymes meant to reform some damaged skin by creating new collagen. However, this process doesn't always work and may result in collagen being broken down instead. When this process is repeated many times, wrinkles develop. In case you still aren't quite convinced, Anna, here's a small sample of the less than attractive side effects tanning may have on your skin.
The sun's UV rays can damage your skin in various ways, especially if you expose yourself to too much of it. Some of these ways include sunburn, which can lead to a number of complications such as putting yourself at risk for infection, uneven pigmentation, although that doesn't mean that people with dark skin are not prone to sun damage, liver spots, labial lentigio, or dark lesions that develop on the lower lip, saggy skin due to breakdown of connective tissue, which includes collagen and elastin. This is why sun damage can make you look like you're aging faster. This process, also known as photoaging, can result in fine red veins on your face, thinner skin, and white macules. Melasma, or the mask of pregnancy, may occur as a result of high sun exposure. Actinic keratoses, or rough scaly patches on the skin, can progress into squamous cell carcinoma. Lentigo maligna is a type of melanoma. It starts as a dark flat spot that slowly darkens and enlarges. Eye damage is a common effect of UV rays as well, due to retinal damage. They burn your eyes, which can eventually lead to cataracts. Cancer can result from the damage the sun does to the DNA in your skin cells. One mutation can result in hundreds and thousands of mutated cells. Excessive UV rays also suppress the immune system. The United States Department of Health and Human Services has classified exposure to sun lamps or sunbeds as known to be carcinogenic to humans.
If the damage caused by tanning and ultraviolet radiation is worrying you, it should. No matter what, appearance is not worth risking your health and your life. Still, you don't have to worry that you'll be the only one who avoids the sun. As society's perception and understanding of the damage caused by tanning increases, many women, including well-known actresses, have become comfortable in their own skin and avoiding tanning. After all, isn't smooth, pale skin more attractive than leathery, wrinkled, tan skin? If you still insist on tanning, there are safer, sunless ways to achieve that tan appearance, particularly the use of spray tans and bronzer. Regardless of what you choose in, the most important thing is that you value yourself for who you are, not what you look like. When you're happy in your own skin, your own inner beauty will shine